This new planet is called Proxima B, and that's because it was found orbiting the star known as Proxima Centauri.
For years, scientists have gazed toward Proxima Centauri, our nearest stellar neighbor, captivated by the presence of its intriguing exoplanet Proxima B. Orbiting within the habitable zone of its red dwarf star just 4.2 light-years away, Proxima B has long been a prime candidate in the search for extraterrestrial life. But now, something extraordinary has unfolded. The James Webb Space Telescope JWST, with its unparalleled infrared sensitivity, has detected something that has shaken the scientific community to its core. Structured, repeating light signatures emanating from the planet's night side. The pattern and spectral characteristics of these lights resemble nothing naturally occurring. Instead, they bear an uncanny resemblance to artificial illumination, much like the city lights seen from orbit around Earth. Before we start, smash the like and subscribe buttons for more updates. The discovery did not happen all at once. Over several months, the JWST had been conducting long-term observational campaigns on Proxima B, using its near-infrared camera NIRCam and mid-infrared instrument MIRI to capture detailed thermal and reflective data. Initially, researchers aimed to study atmospheric composition or perhaps identify biosignatures such as water vapor or methane. However, during these prolonged observations, a persistent anomaly emerged. Faint glows that appeared on the planet's dark hemisphere, flickering in a way that strongly suggested artificial origin. This wasn't just reflected starlight or volcanic glow. These emissions showed consistent wavelengths and structured distribution, exhibiting patterns strikingly similar to electrical grids observed on Earth from space. What elevated the mystery was the repeatability and regular timing of the signals. When Proxima B rotated into its night phase, the lights appeared in clusters, illuminating and dimming in a consistent rhythm. Their intensity and layout indicated they were not fires or natural thermal emissions. Instead, they followed a grid-like pattern, suggestive of organized infrastructure. Such a signal could not be explained by known planetary processes. The only conclusion that made sense, at least based on Earth analogs, was that these lights were artificial, perhaps the result of advanced civilization harnessing energy for nighttime activities. The implications of this observation are staggering. For decades, the search for extraterrestrial intelligence SETI has relied heavily on radio signals or atmospheric spectroscopy, hoping for biochemical signs of life or interstellar communication. But city lights? This crosses a new threshold. City lights mean not just intelligent life, but a civilization. One capable of generating electricity, building infrastructure, and maintaining urban environments on an alien world. If these lights are truly artificial, then Proxima B may not just host life, it could host a society. Proxima B is only slightly larger than Earth and receives about 65% of the light our planet gets from the Sun. Despite orbiting a volatile red dwarf, it lies within the star's habitable zone, where temperatures could allow for liquid water. The existence of an atmosphere, though difficult to confirm due to stellar flares, has been speculated upon. Until now, debates raged about whether conditions could support life, let alone a technological civilization. But with the detection of these structured light emissions, speculation has been replaced with a wave of focused scrutiny. If a society does exist on Proxima B, it must have adapted to the intense stellar activity of its sun, perhaps with advanced shielding or subterranean infrastructure. That, in turn, suggests not only intelligence but technological maturity. More strikingly, the energy efficiency of the lights is notable. On Earth, city lights emit across a broad spectrum, but alien civilizations might have optimized lighting for reduced energy loss, possibly using narrow bandwidth sources invisible to the naked eye but clear in infrared. That's exactly what JWST has detected, specific emissions in the near and mid-infrared range that don't correspond to natural thermal radiation. These emissions display a spectral profile indicative of directed energy use, akin to LED lighting or other advanced illumination technologies. Engineers and astrophysicists studying the JWST data were initially cautious. Any claim of artificial light detection would require rigorous verification. Alternative explanations were exhausted. Could it be auroras, lava flows, or chemical luminescence from atmospheric particles? Yet none of these natural sources could account for the spatial organization and timing of the signals. Moreover, the consistency of the emissions over several months, tied to the planetary rotation and aligned with presumed urban clusters, tilted the balance toward one explanation: intelligence. Further analysis added depth to the findings. Infrared mapping of the planet's surface suggests temperature differentials consistent with urban heat islands, zones where surface temperatures are slightly elevated, presumably due to infrastructure or energy use. On Earth, such patterns are clear indicators of human development. Seeing similar thermal footprints on Proxima B lends even more weight to the hypothesis. And beyond the heat, the lights are stable, structured, and too bright to be mere geological phenomena. Speculation is now moving into modeling. If this is a civilization, what stage might it be at? Are we seeing the energy signature of a Type 1 Kardashev civilization, one that harnesses all the energy available on its planet? Or something more? Given the constraints of a red dwarf system and potential threats from stellar flares, any civilization on Proxima B would have to be extraordinarily resilient. They might live underground or possess planetary-scale electromagnetic shielding. Their energy systems could be decentralized, renewable, or quantum-based, allowing for highly efficient lighting and heat distribution with minimal waste. The geometry of the lights is also telling. On Earth, city layouts reflect historical, geographical, and socio-political forces. On Proxima B, the patterns appear less organic and more deliberate. Initial images suggest radial and grid-based formations, possibly implying centralized planning or a unified planetary governance. This could mean a civilization that has achieved a level of coordination and stability beyond our current global state. While Earth's telescopes cannot resolve structures directly, the aggregate light and heat data allow for modeling of urban densities and potential population estimates. Early simulations propose that if these lights correspond to human equivalent luminosity per capita, Proxima B could host several million to perhaps hundreds of millions of inhabitants. These are rough figures, of course, based on energy output assumptions and distance-based attenuation, but they suggest more than just isolated settlements. They imply a thriving, perhaps even planet-wide civilization. The absence of direct radio signals from Proxima B now takes on new context. Previously, the silence from that region of space was interpreted as a lack of intelligent life. But if artificial lights are present and no radio transmissions have been received, it suggests that the civilization may not use radio at all. They could be using quantum communication, optical laser pulses, or some other exotic technology beyond our detection capabilities. Alternatively, they may be deliberately avoiding transmissions, practicing communication silence either for privacy or self-preservation. Environmental factors are also now part of the conversation. What kind of biosphere could support such a civilization? Are these beings carbon-based, or do they rely on entirely different chemistry? If they have cities and artificial lighting, do they also have agriculture, transportation, and digital infrastructure? And crucially, how did they survive the harsh conditions of a red dwarf system, known for its intense flare activity, which can strip atmospheres and fry electronics? The presence of such lights implies that they've overcome these hurdles, perhaps mastering climate control or terraforming techniques. The philosophical impact is just as profound. For centuries, humanity has pondered whether we are alone. Now there may be light-based evidence suggesting we are not. This shifts our entire perspective on the cosmos. Proxima B, once a dot in our telescopic maps, now seems to shimmer with life. The nature of that life, whether cooperative or competitive, peaceful or aggressive, remains unknown. But its mere existence would answer one of humanity's oldest and deepest questions. The scientific community is now organizing new missions. Observatories around the world, including the extremely large telescope in Chile and the Square Kilometer Array, are focusing on Proxima Centauri. New satellite proposals are in the works, designed to resolve even finer details of Proxima B's surface and atmosphere. Some call for a future interstellar probe, a robotic emissary that could confirm up close what the JWST has hinted at from afar. Such missions, though decades away, now feel not just aspirational but necessary. In cultural terms, the detection of city lights on Proxima B is reshaping everything from art and literature to geopolitics and theology. Questions of contact, diplomacy, and coexistence are no longer abstract. They are grounded in data, awaiting deeper confirmation. And unlike earlier UFO-related hype or ambiguous signals, this is hard science. Measured light curves, verified instrumentation, repeatable observations. It's not conjecture, it's infrared reality. This moment is also a mirror. Seeing the glow of another world forces us to reflect on our own. Our cities, visible from space, speak to our triumphs and excesses. Perhaps Proxima B offers not just the knowledge that we are not alone, but a vision of what another civilization could look like, what it means to build, to illuminate the night, to endure. And in that reflection, there may lie hope, guidance, or warning. Though it may be years before we fully understand the nature of the lights on Proxima B, their discovery marks a turning point, not just for astronomy, but for humanity. Something is there, not a natural wonder, but a signal of intelligence shining across the void. City lights flickering under an alien sky, waiting to be understood. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on City Lights Proxima B? Will aliens reveal themselves? We want to hear from you. Thank you for watching, and see you next time.